Hey, hello everyone. Welcome to our fourth lecture. So my name is Junyu, and I'll be going through smart contracts and Solidity today. So firstly, if you all don't mind, maybe you can come see a bit closer. Okay, so firstly we'll go through a quick revision of a previous lecture. So the previous lecture, Derek talked about transactions and messages, and also about the concept of gas. And I'll quickly go through that. So the Ethereum blockchain is, you can define it as a cryptographically secure, transactional singleton machine with a shared state. So this sounds like a handful, but let's break it down. So cryptographically secure is something that we have already gone through many times using digital signatures and hashes. The hash chain ensures that the blockchain is cryptographically secure. For transactional singleton machine, so what happens is that everyone on the blockchain is sharing the same instance of the Ethereum virtual machine. That's why it's a single instance of the machine for all transactions, right? So all users on the network share one global truth. And lastly, this blockchain is open and shared by everybody. So what is the Ethereum virtual machine? Okay, it's basically a transaction-based state machine. So a state machine refers to something that will read a series of inputs, and based on these inputs, will transition to a new state. So for example, you can take a look at like state 1, and maybe in state 1, let's say your account balance is like 10 Ether, right? Based on the transactions that happen, maybe like somebody gives you 5 Ether, the EVM will process these transactions and transition to a new state. So in state 2, your account will say that you have 15 Ether, for example. Right? So everybody's instance of the EVM will process all the transactions in the blockchain, and their Ethereum virtual machine will all reflect the same state in the end. Okay. So the EVMs are designed to operate as a runtime environment for smart contracts. So on the EVM, what it really runs on is the Ethereum bytecodes or opcodes. However, these opcodes are very difficult for programmers to understand. And if you keep programming in a low-level language, it's easy to make mistakes. So that's why people have come out with high-level programming languages like Solidity, Viper, and Serpent. And for today's lecture, we'll be going through how Solidity works. Okay, so transactions. Transactions can be sent from an externally owned account, and externally owned accounts are accounts that are owned by a private key. So you can read and write onto the blockchain, and messages are considered as internal transactions. So they are sent from contracts to contracts. So if you take a look at the diagram below, an externally owned account owned by a private key, which will be an account that one of us will own, can send a transaction to a contract account. And then if a contract account wants to call another contract account, it will just send an internal transaction, also known as a message. So these are the stuff that are contained in a transaction. Okay, I won't go through this because we already went through it in the previous lecture. So now we also have this concept called gas. So every computation and transaction on the Ethereum virtual machine will incur a gas fee. So the reason for this is to prevent like someone from hogging up the state of the EVM, right? For example, you can write a function that runs a infinite while loop on the EVM. And the EVM is just going to keep running your code on, and no one else can process the transactions. So in order to prevent someone from hogging up all the resources of the EVM, there's this thing called gas, right? So every computation you do on the EVM requires you to pay some gas. So gas is the unit used to measure fees, and it's measured in Gray, which is 1 times 10 to the power of negative 9 Ether. Okay. So this is so when you put a transaction onto the Ethereum blockchain, there will be a gas limit and a gas price. So gas limit is the total amount of gas that you're willing to use for the entire transaction. And gas price is the amount of gas you're willing to pay for each unit of gas that you use. So gas limit times gas price is the total gas fee, right? And if you put a higher gas price, it incentivizes miners to include your transactions in their block because they earn more from doing so. So unused gas is refunded. So if you follow the diagram, let's say you're the sender and you start with 250 gas, right? From the first transaction, you do an operation on the EVM and it costs 100 gas. From a second operation, it costs another 50 gas, right? And now the transaction is complete. So there's an excess of 100 gas left, and this gas is refunded to you, okay? Now if you don't include enough gas, what happens is that your transaction doesn't go through, right? So whatever state that the EVM was, so let's say the EVM is in state A before the transaction, right? And if there's a successful transaction, you'll go to state B. But if you didn't provide enough gas, the EVM will revert back to state A, right? Out of gas, it reverts state. But this gas that was already consumed is not returned to you, right? Because the miners did the work in calculating the state of the EVM, and they have to be paid accordingly. So the gas is not refunded. Okay, so lastly, gas is also used to pay for storage. So whatever code that you write, whatever information is stored on the blockchain, you have to use gas to pay for this, right? It's proportional to storage size. So it incentivizes users to keep data small. So for today's topic, we're going to be talking about smart contracts, right? And these smart contracts are stored on the blockchain. So it makes a lot of sense to optimize your code such that it's as short as possible and it's as quick as possible so that it doesn't use up too much gas when you store it on the blockchain. So optimization is important when you're writing smart contracts. And lastly, if your transaction frees data, gas will be refunded. Okay, so far, like, any questions? Oh, okay. So if I'm speaking too fast, you can also let me know. Okay, so for today's agenda, we will be going through smart contracts, and then Solidity, syntax, and data structures. And then we'll be practicing some simple like Solidity coding exercises together. Okay, so smart contracts. Like, anyone has any idea what a smart contract is?
It's contracts that's pretty smart.
That's pretty true.
That's deep, right?
That's deep. Anyone else has a similar answer? Yeah.
A contract can be enforced by code.
Okay, so he said a contract that can be enforced by code. Yeah. So that's pretty correct, partially correct. Yeah. Okay, so let's use an example to illustrate the point, right? So let's say you want to sell a house. So when you want to sell a house, it's actually quite complicated, right? Firstly, you gotta let's talk about the issue of like trust. Right? Let's say I'm gonna sell a house to you. So do I give you the keys first, or do you give me the money first? Right? Like from my point of view, it's always okay. You give me the money, and I'll give you the keys to the house. But from your point of view, it's always I give you the keys first, and then you will give me the money. So there's this issue of trust, firstly. Right? Secondly, there's also the issue of like complex paperwork, right? Maybe this house has a different selling point, different selling price, different rates. Different houses have different like things going on. And basically, like you guys know that when you want to sell a house in real life, there's a lot of complex paperwork involved. So what most people do is just to hire a real estate agent, right? To sort out all of this stuff for them. They just get a real estate agent who will market the property, sort out the price, also arrange the payment issues for them. However, if you hire a real estate agent, okay, let's assume firstly that you can trust the real estate agent not to run away with your money, right? So firstly, you trust the real estate agent. And afterwards, the real estate agent charges you a hefty commission fee. Right? So in the end, you're still paying a lot for this extra service. And after you pay the commission fee, maybe you don't even earn that much from selling the house. So let's enter smart contracts, right? So you say contract enforced by code, right? That which is pretty much true. So smart contracts work on a if-then principle, right? For example, like if the smart contract receives the money, then it will release the keys to the next person, to the next owner, right? If the smart contract obtains the keys, then it will release the money to the person who sold the house. So smart contract is basically a if and then, right? If I get this, then this will happen, okay? And it also works as an escrow service. So since the money and the digital keys are locked up in the smart contract, then there's no way for anyone else to get them, and it's only automatically released when the conditions are met. So in fact, we already have something very similar to a smart contract in real life. It's a vending machine, right? So a vending machine is basically like a smart contract. You put in money, and then if you put in enough money, you can order like a snack, and then you just distribute it to you, right? If you don't put in money and you press the button, nothing is going to happen to the vending machine, right? So why do people have vending machines, right? Firstly, it's autonomous. Now you don't even need to have someone standing there and selling you snacks all the time, right? There's a vending machine there 24/7. It does the work of a human much better, I think, and yeah, you don't have to pay the human to like operate a store for you. So that's where savings come in, right? Savings from, you just buy one machine and then it lasts you for a lifetime. And it's very efficient as well. But there are also some issues with the vending machine, right? So the vending machine is just a black box, right? You don't even know what's going to happen. For example, like maybe on the $1 millionth that's put inside, it's going to explode, right? Nobody knows, right? Nobody knows what's going to happen to the vending machine. So there's this issue of trust and safety. So how do we reconcile like the good points of a vending machine, right? Autonomy, savings, efficiency, with a smart contract. So smart contracts are actually programs deployed on the Ethereum blockchain and are executed by the Ethereum virtual machine, right? So because you deploy it on the Ethereum blockchain, it guarantees you trust in a way that violation of the contract requires subverting the entire network. Okay, so what does this mean, right? Like previously we talked about Bitcoin. If you try to put like a fake transaction or you try to mine a fake block, it's not possible, right? Because the rest of the nodes in the network will check your block and make sure that yours will not be verified. So similarly, if you try to like cheat the smart contract in any way, it requires you to actually have more than 51% of the hash power of the entire network in order to submit a new state to the Ethereum blockchain, right? So violation of contract requires subverting the entire network. And this basically allows for secure peer-to-peer agreements that can stay on the blockchain forever. So whatever code that is in your smart contract is actually displayed on the blockchain, right? So if you go to the blockchain, you can check out whatever code that's on the smart contract, and it's transparent for everybody to see. Okay? So for the previous reasons I mentioned, smart contracts are like kind of like honest computing, and it's tamper-proof because of the security guaranteed by the blockchain. So there's also no single point of failure, right? Let's say I'm hosting an Ethereum node on my laptop, and then like you just destroy my laptop. Please don't do that. But you destroy my laptop, right? So the Ethereum blockchain is not going to go down because it's still hosted on every other user's laptop or node or whatever, right? So that's why there's no single point of failure. Even if you destroy my laptop, you destroy Alex's laptop, nothing is going to happen to the Ethereum blockchain. It's still going to be running. So that's why it's decentralized, right? And autonomous code. So some of you all might be thinking about Amazon Web Services, right? They always phrase themselves as brand themselves as a cloud service. But are they really the cloud? Because at the end of the day, it's still owned by Amazon, right? If Amazon puts some kind of secret code into it, you wouldn't know. And if Amazon goes down, the entire AWS will also go down. So that's the idea of like blockchain is the real cloud, if you can say that. Okay, so smart contracts, what can they do, right? So they can store and maintain data. So whatever data you want to put on the blockchain, you can store it and maintain it using a smart contract. So similar to the house selling example, they can manage a contract or relationship between untrusting parties, right? Two people who don't know each other want to do a business deal. They can use a smart contract with an escrow service to make sure that the money flows smoothly. So they can also provide functions to other contracts. So the example for this case is like in Python, you can import different packages, right? Import math, import something. So in smart contracts, you can also import different functions from other smart contracts, right? So that you don't always have to rewrite the same functions for each and every smart contract. You just import from one other contract, the third-party functions that you need help with. And lastly, they also allow for complex authentication. So this is more like a multi-signature wallet. For example, like 3 people can own the keys to a wallet, right? And then let's say like 3 of us owns the funds to this wallet. But every time to unlock it, if you require 3 people to unlock it, it's kind of a problem, right? What if one of us dies, right? Then the money is stuck in the smart contract forever, right? Because it's owned by 3 of us. But if one person dies, then you can't unlock it anymore. So what's possible is to have a 2 out of 3, right? As long as you have 2 keys to open the multi-signature wallet, the funds can be redistributed. So something like this can be easily arranged with a smart contract that is deployed on the EVM. Okay? So let's take a quick look at applications of smart contracts. I don't know if you all can see, but that's why I asked you all to sit closer. So I got this from stateofdapps.com, and these are the top 20 rankings of the Ethereum dApps currently on the Ethereum blockchain, right? So you can see there are like exchange platforms, games, trading platforms, CryptoKitties, gambling platforms, all kinds of things for people to make to use smart contracts for. Then now if you all take a look at number 14, it says easy invest, ETH 4% daily, no fees. That sounds pretty wonderful, right? Every day you get 4% of your investment in Ethereum, no fees. So yeah, so I don't know if you guys find this interesting, but we'll take a closer look at it towards the end of our lecture. Okay, just keep it in mind first. Okay, let me drink some water. So now that we've gone through smart contracts, right? The rest of the session I'll be talking about Solidity. So I'll be introducing some like basic data types and data structures in Solidity first. And then for the front part, it might be slightly technical, so do your best to follow along. And if you have questions, just raise your hand and ask me on the spot. So after I go through this part, then we will be practicing on some code together. Okay. So what is Solidity, right? Solidity is a statically typed contract programming language that has similarities to JavaScript and C. So if you already know JavaScript, then Solidity will be much simpler for you to understand. So what it means by statically typed, right? It's like we can have a show of hands. How many of you all here know Python? Oh, okay, very good. How about JavaScript? Oh, okay, then I don't need to teach already. Okay. Anyway, so in Python, you know that you can, like for a variable, you can just say like a equals to 5, right? Or a equals to something. And the Python compiler will know exactly what type the variable is, right? It decides at runtime. But for Solidity, it's not the case. You need to define what type of variable is. For example, you need to say integer a equals to 5. Right? The difference between being statically typed and dynamically typed is that a statically typed language, you will do the type checking at compile time. For Python, which is dynamically typed, it does the type checking at runtime. Okay? So that's one difference, and take note of that. So like objects in OOP, object-oriented programming, each contract contains state variables, functions, and common data types. So Solidity is basically like contract-oriented programming. And contract-specific features include modifiers, events, and custom global variables. Okay, but we won't be going through the third point for today. Okay, so let's take a look at a simple bank contract, right? For example, if you want to write a smart contract that can do the functions of a bank, what do you need? You need to be able to deposit funds. You need to be able to withdraw funds. You need to be able to check balances. Okay, so for the slides after this, right? Actually, I got most of them from learnxinYminutes.com. It's a website. If you guys want to go back and read up more, you can go to this website. Okay, so let's take a look at this smart contract. So this is a basic smart contract. At the top, you can see contract simple bank, followed by the state variables. Okay, just take a look at the words in black first. Okay, balances and owner. After that, okay, you skip the next two lines, and then you have three functions here: deposit, withdraw, and balance. Okay, so this is a simple structure of a smart contract. You have the state variables, and then you have functions that can be called. Okay, like it looks slightly confusing, but let me go deeper into it. Okay, so let's go through the basics of Solidity. So firstly, UINT is untyped integer. Okay, so untyped integer is used for currency amounts, and it's basically like it ranges from 0 to 2 to the power of 256. Okay. Yes. Oh, unsigned integers, yes. Unsigned integers. So UINT is unsigned integer. And you can also have a signed integer, which is just int. Okay? So UINT and UINT256 are basically the same thing. So if you write UINT, the Solidity compiler knows that it's UINT256. And if you add so let's take a look at the second line, int constant a equals 8. So the keyword there is constant, right? If you put a constant, it makes sure that the variable is constant, and once it's initialized to the value of 8, it cannot be changed afterwards. Okay, so now for this part, it says int256 public a equals to 8. So the keyword here is public, right? By default, all variables are initialized as being internal, so they can only be accessed from within the contract itself. But when you put a public there, they can be accessed from outside of the contract. So any functions that are outside of your current contract can also call this variable a, in this case. It needs to be explicitly set to be public, so because by default it's internal. So for unsigned integers, you can also set them in steps of 8. So UINT 8, UINT 64, UINT 248. Okay, so for example, UINT 8, right, will be a smaller range of numbers that you can represent. So it's 2 to the power of 8, which is 256. So UINT 8 will represent all numbers from 0 to 255. Right? And UINT 64 will give you a much wider range of numbers. So why is this important, right? Why is this like UINT 8, UINT 256 important? So if you know specifically that the number that you're going to use is a very small number, it's safe to use UINT 8. So it takes up less space, and your code will be more optimized, which helps you save on gas gas fees, like we talked about just now, right? But it's also very important to make sure that you use the correct UINT type for your integer. So, anyone here knows what is integer overflow? Like integer overflow, anyone knows? Okay, I'll show you a quick example. Okay, so here you have a simple smart contract overflow. So there's two functions here, function minus and function add. Okay? This function minus will take in a UINT8 variable A and UINT8 variable B. And then you return A minus B. So it's a simple like minus function. And then for add, it's the same thing. It just returns A plus B. Okay, so let's try to deploy this. Okay. So for example, like I want to add two numbers together, right? So I can say like 250 and 5. And then if I add, it gives me 255. So far that's correct, right? 250 plus 5 is 255. Okay, so now if I put 250 plus 7, what do you guys think the answer will be? Like, how many of y'all think that the answer will be 257? Just a quick show of hands. Oh, nobody. Okay. Then what would the answer be? 1? Okay. So why does it overflow? Yeah, correct. So basically because we set here to be unsigned integer 8, right? So the largest number you can go to is actually 255. So anything above 255, for example, if I add 250 and 7 together, it's going to give me 1. So it wraps around and goes back to the start point. Okay? And same for the minus, right? If I minus all the way back, it's going to wrap around as well. So actually, this integer overflow, right, is very important when you're writing your smart contracts. So you must make sure that you're using the correct integer type for your variables. If not, for example, like let's say you're supposed to have more money, right? Let's say you have $250 in your account now, and then I add 7, and then now your account becomes $1, right? So clearly something is wrong, and you don't want that to happen on a smart contract. So it's very important to make sure that you're using the correct integer types. And in future lessons, we also teach you how to use like libraries to use the correct mathematical functions, so that such integer overflows will not happen. But for now, just take note that this can happen in Solidity. Okay, so there's also typecasting. So for booleans, like you can put like boolean b equals to true. You just initialize the variable, and then you can cast it to an integer as well. So integer x equals to integer b, and then that will give you integer x equals to 1. Okay, so now let's go on to addresses. So as all of you all know in Ethereum, there's an address for each account, right? So the address is actually a 20-byte Ethereum address, and this address variable keyword is a keyword on its own. Okay, so with addresses, you can transfer money to them. Okay, so the function is actually address.transfer a certain amount. Okay, so what happens here is that the address is the address that you're going to transfer to. So in the smart contract, if you call address.transfer, you're going to transfer this amount of money to that particular address. And the amount of money that you want to transfer is specified in the amount. Okay? And this amount, the base currency is always in Wei. So Wei is actually 1 times 10 to the power of negative 18 ether. Yeah, so just take note. But you can also specify it in terms of ether. So you can write 1 ether, right? Dot transfer 1 ether, and then you transfer 1 ether. So if you just want to find out the balance held in the contract at that point or in the account at that point, you can also call address.balance, and then you return you the balance of the address in Wei. So for dot transfer, right? So what can sometimes happen is that when you try to send someone money, the send function can actually fail. So dot transfer makes sure that if it fails, you'll revert the state back to the original, meaning that whatever money you send out will not actually be sent out, it will be reverted. So you get the money back, and that person's account wouldn't have the money increased, right? And it also give you a false variable. It will return you a false if your transfer fails. Okay. Then below you see on the third line there's a address.send. So .send does almost the same thing as transfer, right? You send someone money, but for .send, if the send function fails, it return you a false, but it doesn't revert the entire state. It doesn't throw an error as well. So that's why over at the bottom you have if owner.send and then do something, right? So you need to wrap the owner.send in a if clause to check that if the send function fails, then you do something about it. Okay, but if you don't want to go through all this trouble, just use owner.transfer. Okay? So usually the current convention is to use address.transfer. It makes things much easier when you're programming. So far, like, any questions?
Why was send even used and why aren't you using transfer?
Alex, do you know? I think send was the original function that they made, right? Then they came up with transfer afterwards. Yeah. So initially the first function that they used was send. And then someone hacked the Ethereum blockchain like using this function. Like, okay, it's not that simple, but basically they came up with owner.transfer to make things like safer when you program. So like if something goes wrong, then you just revert and throw you an error message as well.
And another thing I think is sometimes even if it fails, in some circumstances you don't want it to just simply revert, because address.transfer will revert the entire thing. So whatever that happens before this function call, all the state updates will be reverted, because if at a certain point during this function call, if something gets reverted, everything will get reverted in this function call, basically. So in some cases, if just one of the steps, a few steps are like the transfer or the send doesn't get through, you want to continue executing some other codes. You don't want the entire function code to be executed, to be reverted. That's why I think they have two different money transfer functions.
So basically there's some ability to customize like what happens after the send function fails if you use owner.send. Okay? Okay, so now we also have bytes. So bytes are basically like a array that can store byte. And then you have byte A, which is just bytes 1. So bytes 1 means that it can store 1 byte. And then you have bytes available from 1 to 32. So you have bytes 2, bytes 3, all the way to bytes 32. And bytes 32 is just an array of bytes that can store up to 32 bytes. Okay, so you can determine the length of it on your own. But sometimes when you have input data coming in, you don't know how long the input data is, and you want the array to be dynamically sized. So you can just use bytes, right? BYTES without any numbers. So it'll be a dynamically sized array, and then so it's basically slightly more expensive. So if you already know the size of your input that's coming in, you can just use bytes 1 or bytes 32. But if you're unsure of the length coming in, you can just use bytes. Okay, so for strings, you use like this quotation marks to enclose them. So string n equals to open close hello. Okay. Now strings are much more expensive as compared to bytes. So when possible, try to use bytes in your code instead of string. And so in Solidity, you can also do like type inference, like var a equals to true, right? And Solidity will know that a is actually a type of boolean. But this is like not really recommended because the inference might provide the wrong type. For example, like if you're like we're talking about integer overflow just now, right? If you don't want your integer to overflow, then you should specify the correct like integer size that you need. For example, like if you put integer 8, but then your counter might overflow. So what you actually wanted was integer 16, for example. So just be sure to set the correct variable for whatever use case you want to have. Okay, yes.
Why is string more expensive than bytes? And is string also dynamic type?
Is what?
Is string also dynamic types? Sorry, the dynamic assign array.
So actually, I'm not like completely sure though. You can just say
Yeah, I mean, yeah, it is. And the reason why, because I don't think the microphone can hear, but so you probably can repeat. The reason why string is more expensive than bytes is because of the encoding. Okay, encoding is we want to use, for example, alphabet letter A to capital A to capital Z, A to Z, or if it's a Chinese character, Japanese characters. Usually you're using like UTF-8, which is one of the encoding scheme, and that basically takes a much bigger, I think 16 bytes or something to store one of the one character. But then when you're using bytes, every character is being encoded using ASCII code. So ASCII code only takes 1 byte. So basically 1 character, 1 byte. Okay. So that's why string usually, even if you're using hello, in string you will store the storage will cost twice as much compared to using bytes, although they are like the same. All of them are storing the characters. Anyway, that's it.
Okay. Okay, so you can also assign a function to a variable. For example, here you have a function A, which takes in a unsigned integer x and returns an unsigned integer, right? So it just returns x times 2. So you can assign A to f as well. So var f equals to A, right? And f22 will give you 44, right? So basically, f is the same as function A. And you also have a delete keyword, right? So when you use delete, the value will always be set to the initial instantiation value. So for example, all values are set to 0 on instantiate. For example, if you write integer A, right? The value of A is actually 0 right at that point. So you put like, let's say uint x equals to 5, and you call delete x. So what actually happens is that x is now equals to 0. Okay? So when you use delete, you're actually assigning the variable to its initial value that is given at instantation. Okay?
Question: why returns unsigned integer? Why there is no? Why there's only a type, not a
Okay.
particular variable?
Okay, good question. So okay, so the question is like for the input, right? You have unsigned integer x, right? Then when you return, why is it just unsigned integer? So you can also put returns unsigned integer x if you wanted to. Then in your function you will write x equals to x times 2, right? But if you don't want to do that, you can just write return x times 2. And then in your return code, you just have to put the type, that's all. You don't have to put a variable name. But if you put a variable name inside, okay, let me just show you. How about okay. So let's say I put 10 and 2, right? Oh, sorry, wrong one. Minus 10 and 2. Yeah, so over here, it doesn't say like return C, right? I just assign the value of C to be A minus B. And then the function I put the type and the variable name. So the compiler knows to take the value of the variable inside the function. So here you have C equals A minus B, and it just returns the value of the variable C inside the function. Yeah, which returns here 8, if you all can see. Okay?
One more caveat. What happens if the function body is entirely, there's nothing inside the function body? What will happen?
I think you throw an error.
No.
Okay.
No, so this is related to what's get initialized when you are creating a function, when you're deploying this function. So the compiler will go through the function definition, which basically says when you go through, like this function is called minus, the name is minus. Okay, it has two inputs or two parameters, and their type is all unsigned integer 8, and then their names are A and B. And then during this function initial declaration, you already specify a return variable, which is called C. So at that time, when the compiler is going through this line, they will initialize all of these three values. Okay, so if there's nothing in the function, all of these A, B, C will be equal to 0.
Okay. Yes, thank you.
If I'm wrong, that would be very awkward.
Yeah. So I redeploy the function, the contract, and for the minus function, if I click here, so it returns C equals 0.
You can try enter any other value of A and B, but it will still return 0.
Yeah. So because we didn't assign any value to C, so C is still 0, like what Alex said. Okay. Okay. So like any other questions? Okay, so now we can go on to arrays, and arrays are basically it's kind of like in Python, right? Like a list. So you can just have a static array of fixed length, like 5, or you can, if you don't put a number inside, you'll be a dynamic array of unfixed length, I guess. So in order to add a new variable, in order to add a new element into the array, you just use dot push. And to get the length of an array, you can use dot length. Okay, this works for bytes, but this doesn't work for strings. So you can't index into a string or get the length of a string with dot length. It only works for bytes. Okay, and similarly, like in Python, if you want to have a multi-dimensional array, you just have like you just set like two square brackets. Okay, so for dictionaries, like if you guys are familiar with dictionaries in Python, it's very similar to mapping in Solidity. So over here you have mapping string to unsigned integer balances. So the key value here is string. The key here is string, and the value is unsigned integer. So an example will be you have balances, and you put a string here Charles equals to 1. So it means that inside this mapping, the key value Charles will return you a value of unsigned integer 1. Okay? Then, for example, here you can try like logging the word balances and the name Ada, right? And it's going to return you 0 because you didn't set any value for Ada over here. You only set a value to the key of Charles. So everything is initialized to be the value 0. So Ada will just return you 0. Okay? But if you put dot balances Charles, they return you 1 because you set it over here initially. Okay? Yes.
One more thing, I don't think in Solidity you have console.log.
Yeah. So in Solidity you don't have console.log, but it's like
In JavaScript.
yeah, this is in JavaScript.
Demonstration.
Yeah, but just for like to make it easier to understand how like mappings work.
Do everyone understand how mapping works? Okay, that's great.
Okay.
And also you discuss how to add something and how to delete something. What happens when you delete something in the map?
Oh yeah, it's coming up.
Oh, come out, sorry.
Yeah. Oh, so okay, in order to add something, you can just do it like this, basically, right? Balances. Let's say you're gonna put Alex balances, and then you put Alex here equals to 5,000, for example, right? That means that in this mapping of balances, there will be a key with Alex and a value with 5,000. So that's how you add something. Yeah. So if you want to delete something from a mapping, you have to put delete balances and then the key value that you initially put, right? So for example, you put delete balances Alex, it's going to return you, the next time you search for balances Alex, it's going to give you 0. Okay? And the key point here is that you can't just do delete the entire mapping. So this doesn't work in Solidity. Like if you try to delete the entire mapping, it's not going to happen basically. And then you can also have nested mappings. So you can have a mapping of address to another mapping, which is a mapping of address to unsigned integer. Okay, so you can nest mappings within each other. Okay, like any questions for this slide?
Just to
Yes,
clear up
yes,
the
yes.
confusion, because the example delete balance John is, you know, you can, because the mapping you declare up,
Oh yeah, okay.
the first mapping is different, right? Yeah, so delete John is basically, can only be used in this mapping, right?
Oh, you mean as compared to the,
Yeah,
okay,
it's not
okay.
custodians, I'm just
Yeah.
yeah, because the type doesn't match.
Okay.
Yeah. And also, just to reiterate what Jun you said, where when you delete, you can delete the entire thing. This is a bit counterintuitive compared to your traditional programming, where if I want to delete the thing, by right, the garbage collector will just swipe away all the things that you store in the database. But then in Solidity case, whenever you initiate a new mapping, the things will gonna be, for example, can you go to the previous example? For example, the balance, right? I declare this mapping is mapping from string to unsigned integer. So if this balance is an empty map, then whenever I query something, for example, I'm querying what string use balances, then it will return me a 0, even if I didn't put anything into this mapping. So it will, all the things will be initialized as 0. When you delete it, it will also be will be like re-initialized as 0. So it wouldn't be go away in a sense. It will return you a null or anything. That's the one point. Yeah.
Public imply that this key can be used by other smart contracts.
Okay, so public here means that it can be accessible from other contracts. Yep.
Can this charts can be used by other contracts?
Yeah, so like from another contract, you can call balancers and childs to find out what's the value that's stored inside this mapping. Yeah.
So, how do you know that EDA is not already stored in it?
Sorry?
How do you know that EDA
Yeah.
is not already in the
How do you know that ADA is not already inside? So if it's not inside, you just return you 0. If it's inside, then you return you whatever value that was stored in the mapping. Yeah.
For the last two guys, right? How come there's an underscore before account? Is it just the name for
Yes.
Yeah.
How you don't need the apostrophe for underscore accounts, but I need for chunks.
Okay, because underscore account is a variable that holds a string. Yeah. So here you're like directly putting in the string itself. But here, for example, it's like underscore account equals to Charles already. Yeah.
So it's like the syntax of the solidity.
Yeah. Like it's already a string. So you can see here that the input is a string. So you put a string here, then it works out. Like it's already a type of string. Yeah.
Just to add one more point on that, why do we need a one underscore at the front? Just to the reason why we do that is just by convention. It's just a good code practices, a good code style basically. It's not compulsory. You can name whatever you want to give to the parameters. The reason why we want add a underscore at the front is because sometimes we declare the same name, same variable under the same name. For example, you want another account in the function. It cannot collide with whatever the parameter is called. So that's why you need usually you have an underscore at the front just to whenever you type, you don't want to confuse with some of the local variable that you declare within the function. That's the reason why you want to underscore at the front.
So a variable name can't collide with the parameter.
Sorry, what?
So if I declare a variable and that's in the parameter of the function, that won't
That won't match.
like you said that just to differentiate between variables that have been defined before and variables.
Oh no, it's not So sometimes, for example, in this balance function, you want to declare some local variable that's local to this function, and sometimes you want to name it account, and you want to distinguish these two variables that using the same name. So and also you want to remind yourself this is a parameter that you passed in, just in case, because many people write many bucket codes, and bucket codes are very expensive and costly, and a lot of these at stake in Solidity. So.
Okay. Any other questions? Yes.
Sometimes you have a long list of names and a long list of balances. What's the efficient way to blend them together?
What's the efficient way to?
So for example, under this one, you just net charge to one. Or
Yeah.
if we have a lot of balances, how can we blend them together?
You can just iterate through your list and store them in the mapping. Yeah. Is that a question? Or like you wanted like a bulk mapping system?
Yeah. Is it just like for loop or?
From what I know, it's just a for loop. Yeah. But I mean, you can write a contract that will do this. Yeah. Okay. Yeah. Any other questions?
Sorry, I just want to add one more point. Regardless how much in any programming language, right? Whenever you want to add something to a dictionary, it's always iterative. There's no like quick add or anything. It's always adding one by one. But the query time is going to be constant because they're using key value pair. So it's not an index array where if you want to query something, you have to query the entire array. It's not like that. It's a key value pair means that the query time, whenever you want to get the value of a certain key, the query time is always constant. Yeah.
That's a good point. Okay, so now we have structs. Sometimes you want to have a variable that's of a more complicated configuration. So it can be made up of basic data types, right? So like struct bank, maybe you want to have an owner and a balance. So owner is address variable type, and balance is an unsigned integer. And then you put in a struct bank. So now bank becomes like a variable on its own. So here you have like, let's say this line of code, bank C equals to bank, message or sender, which is just the address of the person who sends this message, and 5, right? So let me ask you guys, if I call C.balance, what's the output gonna be?
5.
Yeah. So yeah, C.balance is equal to 5. And if I call delete B, what's gonna be the output of B? Yeah. You say 0? Yeah, so everything is just gonna be 0. Okay?
It depends on the data type.
Okay, yeah. But for here, the UINT will be reset to 0.
What about boolean?
Oh, actually, I don't know.
Will be false.
0? 0.
Yeah, will be false.
Okay, then lastly you have enums. So enums allow you to basically set it to be either one of the state, right? You can define enum as the enum to be it's called state with created, locked, and inactive. Then you can set a new variable of this type state, which is called state, and then you can put state equals to state dot created, right? And then if you cast it to be an integer type, you just return you the index of the type in the enum, right? Like created is 0, locked is 1, inactive is 2. Okay, so now we're going to move on to data storage. So in the Ethereum blockchain, you have memory, storage, and stack. Okay, and all the variable types will be stored in a certain data location. So memory is kind of like the RAM of your computer. It's only used when the EVM is processing, and it does not persist between like different contract calls. But storage is kind of like the hard disk in your computer, right? It's always there, it's always stored there. So you persist between different contract calls. Yeah, so memory and storage is like RAM versus hard disk. So the default is storage for local and state variables. And then for your function parameters, whatever you put into the function parameter is usually stored in memory. And the stack will hold like small local variables that are used when you're doing your calculations inside the function itself. They are useful for values in intermediate calculations. Okay. So I also put a link there. If you guys are interested, when you go back, you can go to the link to review more.
Sorry.
Yeah.
I think it's worth mentioning that just like in any other language, anything that's in the memory will be stored. Because in some function, you will declare new variables, which are not global variable. They are a local variable that's local to the function itself, and all of them will get swiped out of the memory once you finish executing certain function. That's one thing. The other thing is when you're calling a function, usually you're providing some parameters to that function, and that parameter will be put on stack. Okay? And there's a limit, there's upper limits on how many parameters you can put on a stack, which is 16. So any function you wrote should not have more than 16 inputs. Okay.
Is the function parameter always stored in the stack?
Yes.
What happens if you go over 16?
Then you will revert. You wouldn't compile whenever you deploy that smart contract. You wouldn't be able to deploy it.
So you get
Yeah, you get it. Yes.
Okay.
If an array is a parameter,
Yeah.
will be counted as one.
No, you will become as one. Yeah.
So whatever variables I'm using in the program, if they have intermediate values,
Yeah.
none of them get deleted, the all of them then it's stored because if they get deleted, they just the value goes back to zero.
Right.
So whichever variables they use in the program,
Right.
all of them are stored. Like in the
Yeah. Yes. Yes. So, Ju and Derek mentioned last time where each smart contract will have their own address, which is their identity. Now, under each address, you will have if it is an externally owned account, which means your account, you will have all the information, including your balances, etc. If it is a smart contract account, you will have your code and also a state tree. And this state tree is also a Merkle tree that's combining all the states within the function itself. And then you aggregate them, and you get a state root of this smart contract. And this state root is the only thing that's being further calculated in the even bigger Merkle tree, and then put it onto the blockchain. Does that make sense? Yeah. So it's not all the variables. The variables itself, or the state of the variables, are not entirely stored in the block headers or anything. Yeah. But it's still part of the blockchain. It's stored in your any node's local machine on your disk.
Okay, so like state variables are always in storage. For example, like your contract, you have like balancers, right? The mapping of balancers that we had just now. So that balancers is always stored in storage. Okay, and then like function arguments are in memory, but you say it's in stack.
Usually it will be pushed onto the stack first, and the variables that declare inside the function will be in memory.
But I thought the parameters are also in memory.
They will be pushed into memory if
Okay.
you use it. But whenever you call a function, you're doing a transaction, and you're providing that. So you are stacking that parameters onto the stack, and when the EVM is executing it, you are popping that parameters out of the stack into your memory.
Okay.
Right.
Okay. Did everyone understand that?
Okay. So the idea is that right now we already knew that the function itself lives on the blockchain somewhere. So now it has a state. For example, state 0. Now I want to update, right? I want to update the states. For example, I want to update GU's balance using the smart contract has a mapping which stores everyone's balance, which is basically a mapping. Now, whenever I want to update the states, meaning I want to change the variables, I will need to call a function call. Now, whenever I do a function call, I do it via a transaction. Okay? So within this transaction, I specify which contract do I want to call. And within this contract, which function do I want to call? And for this function, what parameters do I provide? Now, whenever I do this, when other people receiving my transaction, which I sign, okay, first of all, they have to verify my signature is correct. Once they decrypt my signatures, and once they verify that this transaction is valid, what they will do is they will put onto as we said, EVM is a stack machine. So you're basically stacking the parameters onto the stack machine. And whenever you need to calculate them, you pop them out. And then usually the calculation is not on stack machine anyway.
Yeah.
The calculation is in your memory. So in a sense, it is correct to say that the function parameters are in the memory, but usually they are pushed onto the stack first, and then when you are using them or calculating them, they are usually calculating within the memory. Yeah, hope that makes sense.
Okay. Thanks, Alex. So your local variable is of a type struct, array, or mapping. They're usually stored in the storage by default, but you can set it otherwise. You can say they store in the memory if you want to. And if it's a value type like unsigned integer or integer, it'll be stored in the stack, which is not the storage. Okay. Okay. So now let's take another look at a bank contract that we had earlier on. So at the top you have this mapping of address to unsigned integer, which is basically your address of whoever owns the account, and the unsigned integer is the amount that they own in these balances, right? So that's the mapping, and then you have the address of the owner of this contract. Okay, so you just ignore the event for now. Constructor is basically when you initialize this contract, this constructor function will be called, and this owner variable will be set to the person who is deploying this contract, right? So message is actually you send a transaction to the blockchain where you deploy this contract. So message is their transaction, and message or sender is the person who sent that transaction, right? So the person who sent this transaction to deploy this contract to the blockchain will be the message or sender, and this contract. The constructor function is initializing the owner variable to be the person who is deploying the contract onto the blockchain. Okay? Then here you have function deposit, withdraw. Like withdraw is basically like it takes in a parameter withdraw amount, the amount you want to withdraw, and then it returns the remaining balance, right? So it goes into balances of the person who is sending this withdraw request, and then it minuses the withdraw amount, and then it message or sender dot transfer, right? So you're transferring the withdraw amount to the person who is calling this function, and finally you return the balance. Okay? So we won't go like directly into this contract because there's still some elements that we haven't explained. But I hope that when you guys look at this now, you have a better understanding of how the contract works. Okay, so now we're gonna do some practice.
Sorry, before that, I
Yeah.
have a few questions.
Oh yeah, sure.
What is private?
Okay. So over here you have private. So private is basically the visibility of the variable. So in Solidity you can set it to be private, internal, external, and public. So private means that it can only be called by functions within this contract itself. Okay. Then external is to be called by anything outside of this contract. So let's say if you put this to be external balances, right? Only a function from outside of this contract can call the balances. Okay, if it's external. But if it's within, like let's say if it's external, something from within the contract cannot access the variable. Okay, you all get it? So external is only for functions outside of the contract. Let's say if I set this to be external balances, then this function itself will not be able to access my variable balances because it's external.
Sorry, I might be wrong, but I don't think that's true. From my understanding, private is so public private, they are all like access control term, telling is this variable accessible by somebody, right? This is access control. It's giving permission. Public is anyone can call me.
Yeah.
Any function within this contract, any function from other contracts, any function that is a descendant or someone that inherits from this contract can call me.
Yeah.
That's public. Private is the most restrictive access control term, which means that only function within this contract can call me. Okay. Anyone from outside couldn't query this directly. That's wrong. Private is the one that you can only change or call within this smart contract. They are also protected and external. Protected are those that is callable only within this contract and its descendants. Externals are those that's callable by could be called by other contracts and this contract. I think that's
No, it's outside of the contract.
yeah, outside the contract and this within this contract as well.
No, no,
And
no.
external functions cannot be called from within the contract.
Oh, is it? Okay,
Yeah.
so then I'm wrong. Okay. Yeah. Maybe we should provide a link to this. I think the
Yeah.
documentation there's.
Because actually I didn't want to cover this part in like today's lecture, yeah.
Okay.
But I can write it down very quickly.
Yeah.
So it can only be called by functions from outside of this contract, right? And private is only called by functions within the contract itself. So for public, it can be called by any functions within the contract or outside of the contract. Alex,
Yeah.
what do you say protected was?
Wait, I'll just.
Is it-
I just put the link over there.
Okay, yeah.
Just put it directly. So.
Okay.
sorry.
Okay, so for the practice part, right? I think what work best is if you guys do it in like pairs, so you can still code it on your own, but then like sit together with someone else so they can discuss what's going on. Okay. And then can everyone go to this website, remix.ethereum.org? Like on your laptop right now, please go to this link.
What's
Yeah.
protected?
Okay, I also didn't write. I'll find out. You can go to this link first. Yeah.
I have some things. So.
Okay. Okay, so just to quickly clear up the confusion, so there's actually 4 levels: private, internal, external, and public. So for private, it can only be called by functions within the contract itself. For internal, it can be called by functions within the contract itself, or within any contracts that are inherited or derived from this contract. For external, it can only be called by functions outside of this contract, but not from within this contract. And for public, it can be called by any functions anywhere. Okay? Okay. So is everyone now on on the Remix website? Okay. So can I see? Are you on the Remix? Okay, so on Remix, right, you guys can click on the top left. There's this plus. So it help you create a new file. You just click on the plus, give it whatever name you want, press OK. Okay, then firstly go to the right side of the screen. Okay, under Run, click on the tab called Run. Under Environment, you change it to JavaScript VM. Okay, so this means that the Remix IDE will run in a JavaScript virtual machine. Okay? Is anyone confused? So, yeah. On the right side, go to the Run tab, Environment, set it to be JavaScript VM. Okay, so if you want to open a new file on the top left, On the top left, there's this small plus icon. You click on it. Yeah, then type whatever name you want and press OK. You open a new file in your remix IDE. Okay, is everyone okay? Okay. Okay, so for the first task, right, we're going to write a contract called greeter. It will have a greet function. They'll return the string hello NTU. Okay, then I'll write this together with you guys. So you just follow me as I type. Okay, so now you go to your remix. At the top you can put like pragma, solidity. Okay, so this is just telling the compiler like what version of solidity to use. Okay, it's just a basic line in all your smart contract programs. Okay, then you go to the next line. You type contract. Right, let's call it greet. Put a curly bracket and press enter. So this is the basic basic structure for a contract. Okay. Okay, so we want to write a greeter contract. Okay, we have done that. With a greet method, right, that returns the string hello NTU. So now we need to write a function. Okay, so you write function, right, and you give the function a name. So let's say greet and input parameter. So there's no need for any input. So you just leave the input as blank. Okay, and then you want it to return the string hello NTU. Right, you want it to return a string. So you write returns string. And then you put a curly bracket and press enter. Okay, is everyone there? Okay, but then you notice at the line number 4, right, there's this like yellow exclamation mark thing. So it's telling you about the visibility of the function, right? So it says warning, no visibility specified, okay, defaulting to public. So what you can do here is you can type returns. Okay, so after the greet function you can put public, right? So now you know that this function is going to be public, can be called by any other contract. And then inside the function, you will write return and a string hello NTU. So after every line in Solidity, you need to put a semicolon. It's called a semicolon, right? Yeah, this dot comma thing. Yeah, it's called a semicolon. So after every line, you need to put a semicolon to end it. So, okay, is everyone like at this stage already? So here we have written a simple contract called greet. There's a function inside called greet that returns a string, and then inside the function you just have return hello NTU. Okay. Okay, so now, if there are no issues, okay, you click on the Run tab. Make sure your environment is set to JavaScript virtual machine. Okay, under this greet contract here, there's this pink color button called Deploy. Okay, you just press Deploy. Then you deploy to the testnet on the Remix IDE. And then here you can see your deployed contracts. So greet is actually being deployed. Now if you press the drop down arrow here, there's this pink button that says greet, right? So this is if you click on this, it will actually do a function call to the smart contract that's being deployed, right? So when you click on greet, you actually call this function, right? And the reason why we can call it is because it's a public function. Okay, so the reason why we can click on this is because it's a public function. So if you click on this, what's going to happen is that the function is going to run. It's going to return you hello NTU. So you just click on it, right? And then you open this log over here, and it says hello NTU. Okay?
So if this greet function didn't show up, usually what happens is whenever you load this page, you have to choose the environments. Okay? So whenever you change the environment, sometimes you need to refresh the page. So if you didn't see like the greet function over here, usually just refresh the page.
Okay. Jun, you didn't mention the first line. What the first line is basically doing is this is not being compiled into the actual bytecode. Okay. This is only a what we call directive instruction for the compiler. Basically, I'm telling the compiler that I'm using only compiler version bigger than this, higher than this. Okay. So if, for example, if you go to the compile, do everyone see my cursor over here? If I go to compile and I can select another compiler version. If I select anything that's below 4.25, then it should give me an error. So for example, I choose a 23. There you go. Do you see? The compiler does not match. So he will tell me that I specified the compiler needs to be bigger than 4.25. So that's why I have to choose 4.25. Okay? And then whenever I choose that, it will trigger the online editors to recompile for me. And after a while, it should be ready. Okay? Another thing I want to say is that, as you can see, there are a lot of versions. Just to give you a sense of what these all mean. What does it mean by nightly? What does it mean? So whenever you write a compiler, it's just like writing any software. You need patches, you need updates. Now, there are, once in a while, you need like major updates. So in Solidity compiler, they follow strictly to like an NPM package, right? Any Node.js package. So whenever you have a minor updates, you don't want to tell everyone right now I have a new version. You are basically doing a nightly commits. Nightly commits, you can imagine, is just something I do it in the nights. So whenever you wake up in the morning tomorrow, you still don't know. So the idea is when you see something like 2.5 plus commits, that means that's a major release. So that basically combines all the things that happen from 4.24 and all the nightly commits up until this point. Okay? So the last octets, which is 25, that will increment. Now, the second octet, which is 4, whenever you increase that, it means that incompatible there usually are incompatible changes. So that's an even bigger commits. Sorry, that's an even bigger updates. So as you can see right now, compiler is already being upgraded to 5.0. So there might be some major changes. So whenever you see that there's a new updates, usually the recommended thing is that to go back to the GitHub and see what's actually being changed, so that you need to know some of the syntax are being updated or new features coming out. Yeah, I think other than that. Another thing I think that's worth explaining is this thing over here. Do you see the gray area over there? And Jun, you mentioned that this is like a sandbox, like a test RPC. What that means is that all these contracts, whenever you click deploy, it's only being deployed on your local machine. So no one else in the world knows that you are deploying this contract. Okay? So what happens is that this online editor is basically a sandbox. And this sandbox is implementing a client, which is the Ethereum clients. So you will be the clients. So the smart contract should act exactly the same when you deploy to the real network. So that's the idea. And you can see if you are a node or if you are a miner, these are the things that you will be able to see. So you are the one who's sending the transaction and the one who's processing the transaction at the same time right now. And all the console log over there is going to be something that's seen by the miner or by the full node. Okay, so that's the idea. And the environment, one more note on the environment. If you click on the environment, usually the one you will usually use is either JavaScript virtual machine or the injected Web3. So if you switch to injected Web3, usually you will need to, first of all, refresh the page, and then you will need to connect to your MetaMask. So you have to log into your MetaMask. And the reason why it's called injected Web3 is because whenever you open up MetaMask, MetaMask is injecting code to this website. Okay? So they are injecting the Web3 library to this website so that whenever you click deploy, you're actually deploying it to one of the testnet. For example, Robston, Coven, etc. Okay, so but most of the time you don't want it to deploy to any test network before you test it all the functionality out first. So that's why usually you use a virtual machine first. Virtual machine, basically you're running a sandbox on your local machine. And yeah.
Okay, so anyone has any questions on the code so far? Okay. Okay, so now we try to attempt the bonus part of this question. Okay, so now you're going to try to allow the user to change the greeting string without redeploying the contract. Okay, so one way we can do it is, so in the function greeting, right, you can include a parameter. You can put a parameter for the user to input, right? So we can write here string, let's say like user input, for example. Okay, so now this function will take in a parameter, okay? And then you can set it to be return user input. Okay? So what's going to happen here is that the user can put in some kind of user input into the function. And then when you run the function, it's just going to return whatever the user input. So again, we deploy the same contract. Okay, now it appears over here. So you open it. Now it's under here. You see there's a field that you can fill up. So for example, you can put in double quotation marks, you can put like hello world, right? And then you press the greeting function. So when you open up your transaction log again, you can see that here it returns hello world. Okay, so make sure that you deploy the contract. You deploy the contract again. You press deploy. You deploy the contract. You type whatever you want to the user input, and then you press the function greeting, and then you open up in the transaction log, and you can see that output here is whatever you have typed in. Okay. Okay, so user input is a parameter that I define in the function. So here in this function, you can define a parameter that the function will take in, right? And here I put it as string with the name user underscore input. So here in this function, there's this space where you can put in a parameter to the function when you call the function, right? So if I put in a string here, let's say I put hello, right? Then this hello is now being assigned to the parameter user input. So when you run the function, it's going to return user underscore input. Yeah, just like that.
It's not specific syntax, right? You just put X there.
Yeah. So this user underscore input thing is just a name. You can put like X. Then here you just put return X. Yeah. So it's just a name. Okay, is everyone okay so far? Any questions?
Can I check
Yeah.
you put a comma,
Mm.
then you add on, right? You still need to keep defining what you're adding on. So like after user input, you put comma,
Here.
then you put like integer 5 something like that. But
Okay.
you have to keep specifying your data type as you go along.
Yes.
So if you feed the wrong data type,
Yes.
Why is there like a exclamation mark?
Okay, yeah. Good question. So if you mouse over, it says that okay, function state mutability can be restricted to pure. Okay, so in the function here you have the visibility, right, called public. Okay, then you can also add another keyword which is called pure. And then now the warning disappears. So what pure does is that it means that this function it will not modify anything to do with the state of the contract, basically. Okay, and you also not be able to access anything that's within the message. So like usually you send a message to call this function. So if your function is defined as pure, you'll not be able to access any of the information within the message itself. Okay? For example, you can so basically a pure function is only able to call other pure functions, and it will not modify any state variables within the smart contract itself. So it's kind of like a window, for example. Like you just look at the smart contract, but you don't modify anything within the smart contract itself. Yeah.
without that, you can modify.
Yeah. So if without okay, so Okay, good question. Okay, so let's say I define a variable in my smart contract. So I can put a string public greeting, for example. Okay, whatever. Right? And then now I want to set greeting equals to user input. Okay, then so now I wouldn't, let's say I take away the return first. Okay, so now my function will it's just going to modify the variable called greeting and set it to be whatever parameter you input. Okay? Then just now we were talking about the keyword pure, right? So if I put pure here, it's not going to be possible because I'm actually modifying a variable inside the contract itself. So this function can't be pure. Right? So you remove the pure keyword, then it's okay. Now, does that make sense?
So pure functions can exist by themselves.
Pure functions can exist by themselves. What do you mean?
Like doesn't take any variables from outside.
Yeah. Basically, a pure function just doesn't modify anything within the smart contract itself. Yeah. Okay. But so I'll just show you guys, like if I deploy this contract, right, then you open it, so you can actually see there's like two fields you can access now. Okay, because my function greeting is public and my string greeting is also public, right? So now I can access both the function and the variable itself. So for example, like if I press greeting, right now it's nothing. It's just a null value. Because when you initialize the string, it's just a null value. But then I can set so I can use the function and set it to be like, let's say, hello Alex. And then I press the function. And then now when I press greeting, it's going to be hello Alex. So you're actually changing the state variable stored within the smart contract itself. And that's why the function cannot be pure in this case. Okay, in the previous case, we just returned the string. So like nothing inside the smart contract was modified. And that's why you can put a pure keyword on it. Okay? Okay, let me just... Yes. Oh, it's confusing? Yeah, okay. Oh, for the variable, is it? Okay. So, I think Alex was asking about like, when you set the variable to be like public, right? So how come like you're able to click on this variable over here, even though it's not a function? So what the compiler actually is doing is that it's creating a getter function, and then it just creates an automatic getter function that so this is basically the getter function. When you click on it, it just gets the value of the variable that's public and returns it to you. Yeah. Okay, are there any like other questions? Okay. Okay, so now we'll move on to the next task. Okay, so yeah.
Can you write more than one contract in that?
Yeah. Okay, so now for the second task, so I think you guys should know this thing called the Fibonacci sequence. So it's basically like the next number in the sequence is the sum of the previous two numbers. Okay, so for example, you take a look here, 1, 1, 2, 3, 5, 8, 13, right? So 2 is the sum of 1 plus 1, 3 is the sum of 2 plus 1, 5 is the sum of 3 plus 2, 8 is the sum of 5 plus 3. So the next number here should be 21, right? Because 13 plus 8 is 21. So the next number in the sequence is always the sum of the previous two numbers. Okay, so your task for this part will be to write a contract. There's a function that can output the Fibonacci sequence. Okay, so your function should take in a parameter, for example, like like this. So let's say your function is called FIB underscore sequence. If it takes in the parameter 6, it should return the value of the Fibonacci sequence at the index 6, right? So it is index 1, 2, 3, 4, 5, 6. So if you put in Fibonacci sequence 6, it should return 8. Okay? If you put in Fibonacci sequence 1, it should return 1. 2, it should return 1. 3, it should return 2. 4, it should return 3. 5, it should return 5. 6, it should return 8. 7, it should return 13, and so on and so forth. Okay, so now your task is to write this function in Solidity. Then you can take about like 5 to 7 minutes to write it, and if you guys can't, then we'll go through it together. Okay, good job on trying it out. I think some of you all got it already. So this is the code. This is like the answer. Okay, so like I can deploy this, and then let's say I put like 5, or I put 6 for example, and then I run it, and it returns me 8. Yeah. Okay, so I can quickly run you through the code. So what happens here is that I initialize 2 variables, A and B, right? And then if because for the Fibonacci sequence, the first index and second index are basically both 1. So if I get 1 or 2 for the input, I'll just return you 1, right? A equals to 1, I'll just return you 1. Then now if it's more than 2, right, we'll go into a for loop. Then you iterate through. So the first 2 numbers are 1 and 1. So the next number will be A plus B, right? And then after that, A will be equals to B, and B is equals to the sum. Okay, you can take a while to figure this out. Yeah, then you just run through the for loop for the, let's say like if the number is 6, because you already calculated 2, so you just run through the for loop 4 times. Then you just return the final result, which is 8. Okay, maybe, okay, so okay, let me like make it easier to see. So in the for loop, right, what's going on is that we already have 1 and 1 here in A and B. Okay, so we just want to loop through starting from the second position onwards. That's why in the for loop you have sequence number minus 2. So for example, if I put 6, I'm only looping through the for loop 4 times. So what happens here is that I set a temporary variable to be A plus B. So let's say we put in 3, okay? Then temp will be equals to A plus B, which is 2. So now temp is equals to 2. And then A equals to B, so A equals to 1. Then B equals to temp. So B is now equals to 2 plus 1. Then I return temp, which is 2. Okay, but let's say I put a number here as like 4. So I go through the loop 4 times. 4 sequence number to be 4. 4 minus 2 is just 2, right? So I go through the loop 2 times. So in the first loop, temp will be equals to 2, okay? And then A will be equals to B, so A is equals to 1. And then B is equals to temp, which is 2, right? Maybe you go through the loop one more time. Then now temp is equals to A plus B, which is 1 plus 2. So temp will now be 3. Then A is equals to B, which is now 2. And then B equals to temp, which is now 3. So if I return temp, it should give me 3. So here if I put 4 and I run it, it gives me 3. Okay? Okay, any questions for this part? Okay. Okay, now we'll just quickly go through one more practice task. Okay, so this one is simpler. So just write a XOR function. Okay, so your function should take an input of either 1 and 0. Okay, your function take in 2 inputs. The input can either be 1 or 0. So if your function takes in an input of 1 and 0, the function should return 1. Basically, if your function takes in input that's different, it should return 1. If it takes in inputs that are the same, it should return 0. right? So your function should be able to take in like, let's say 0, 0, and return you 0. If it takes in 1, 1, it should return you 0. Yeah, that's an XOR function. So take about 5 more minutes to try to implement this. Okay, so very quickly, here's the code for the XOR function. So you just check if A equals to B. If yes, return 0. If not, then return 1. Okay, anyone got any questions? Okay, so
They want to ask about the curly braces.
oh yes, yes, yes.
They want to ask.
Oh, okay, yeah. So for if and else, right? If you just have one line under the if and else, then you don't have to have the curly braces. Okay, but if you have more than one line, right, then you require the curly braces. The reason is that, like, let's say you have a few lines under the if condition, then the compiler wouldn't know like where to, like at which part is the under the if condition. So you have a curly bracket to like to encapsulate the conditions for the if. Yeah. But if it's just one line, you can also put the curly braces. So like, yeah, it still works just as fine. Yes. Then in my function it will just return 1. Oh. Yeah, I mean, as in like, this is a very simple function. Yeah, if you want to have more like functionality, you can write like more functions to check the input and stuff. Yeah, but for this exercise, we just assume that your input will either be 1 or 0. So that you want to like take in a parameter as like true or false, is it? Yeah, I think it should be possible. Yeah. Okay, so I'll just quickly go through the rest of the slides and then we can go off. Okay, so actually there's one more task. Is to concatenate 2 strings together and return the concatenation of the 2 strings. So for all of these tasks, right, there's also a bonus part. So at the end of today's lecture, we'll be releasing a quiz, and then you have to submit your code for these tasks in the quiz form as well. Okay? Okay, so now let's just take 5 minutes. Okay, to very quickly look through this contract. So this is the one that I showed you guys at the start. Remember, initially I showed you the apps that are hosted, right? Then there's a easy invest, 4% if daily, no fees, right? So this is actually hosted on the Ethereum blockchain, and this is the code in the smart contract. Here, I'll just quickly go through it with you guys. So here you have a mapping of an address to the amount, right? It's called invested. So basically for each person's address, how much they've invested into this smart contract. Then you have this mapping called at block. So it's just at each address, which was the latest block that they had a transaction in. Okay? So this function is just a payable function. It means that, okay, this payable keyword means that you can send Ether or you can send money Ether, right, basically to this function. Okay, so in this function, what it's going to do is that there's an if condition that checks the amount that you've invested. Okay, if the sender, which is you, right, if the amount that you invested is not equal to 0, okay, it's going to calculate this amount based on the amount that you have times 4% times some number, and then it's going to send it back to you. So for example, if you have like 1,000 Ether invested in this smart contract, it's going to take 1,000 times 0.04 times some like number, and then that amount is going to send it back to you. So it's basically going to send you back 40 Ether, right? You guys follow this part? So it's going to, let's say like the amount invested currently into this contract is 1,000 Ether times 0.04, which is 40, times some like arbitrary number. And then this sender is basically me, right? Because I'm the one sending money to this contract. So sender.send amount. So this contract is going to send me back 4% of my investment, which is 40 Ether, which sounds like a pretty good deal, right? And over here, you have invested, which is the mapping, plus equals to the value. So like if you send in money, right? Let's say you send in another $1,000, then it's just going to record that the amount that you invested is going to increase by another 1,000. Okay? Does everyone understand like what this contract does? So basically, when you send in money to the contract, it's going to log how much money you have sent to it, and it's going to track your balance in the smart contract. Then based on this balance that you have, it's going to return you an amount of commission, like 4% times some. Okay, so over here it just takes the block number, the current block number times the previous time you called this function. So let's say if the previous time you called this function is at block 1, and now it's at block 500. It's going to take 500 minus 1 divided by 5,900. Then this figure times 0.04 times the amount you invested. And that's the commission that you earn. And then it's going to send you back this commission amount. Okay? So in this smart contract, there are some comments in the smart contract. So it says gain 4% every 24 hours, right? No commission on your investment. This is just a smart contract. You send in money, it sends money back to you. So it doesn't earn anything from you, right? No fees are collected by the owner. In fact, there's no owner at all. Just look at the code. Right? So this smart contract is hosted on Ethereum blockchain. There's no owner. So how to use? Send any amount of Ether to make an investment. Claim your profit by sending 0 Ether, right? So over here, if you send 0 Ether, it's just going to send you back whatever commission that you have currently invested in the smart contract. Send more Ether to reinvest and get your profit at the same time. Okay, so contract is reviewed and approved by pros. Okay, so I'll let you guys take a look at the code again. And as you can clearly see, right, this code is already running on the Ethereum blockchain. So there's nothing wrong with it. Like there's no bugs in any of the lines. So does everyone think that this is a great deal, like a great smart contract? Right, it's going to give you free money all the time. Anyone has any idea, like, is there anything wrong with this smart contract? I think it sounds pretty good. Give me 4% money every day. Why not?
Where does the money come from?
Oh, exactly. But that's what the code says, right? It's going to send you back the money. So, yeah, like, along that line of thought, what do you think is, like, is there anything wrong with this contract? Yeah.
What I can think of is related to gas fee. Like,
Yes.
you need to send the 0 to this smart contract every day, so it is going to bring the gas fee. So if the amount of Ethereum you send to the contract is less, the reward after you claim after this contract is less than the gas fee, then you will actually gain a loss. So I think that's a problem I saw.
Okay, so you see that if you send 0 Ether, then the amount of gas they use costs more than the amount you get back, then it's a problem, right? But what if you don't send the Ether every day? Maybe you can just send it once, so you have to collect the money. Isn't it like free money? Because you don't have to send you don't have to call this function every day. You can just call it when you want to get your money. Yeah. Anyone want to try? Because if not, go home and just invest in this already.
It's not giving you Ether.
Oh, it's giving you Ether, it's giving you Ether. Yeah. So here is the part where it gives you the Ether, right? So if your account has balance, invested not equals 0, right? Sender.send amount. Amount is like the amount of like Ether that's gonna send you, basically.
Isn't it just some random variable that this guy named?
Oh, okay, so here you have amount equals to. Okay, so let's say you previously invested 1,000 Ether, right? So invested here will be 1,000 times 0.04, which is 40, right? And let's say you invested in like block number 1. So here will be at block will be 1, okay? Then block the number right now, let's say it's like 10,000 for example. 10,000, then this number here will be 10,000 divided by let's say 5,900, which is about 2, right? So 2 times 0.04 times 1000 is 80 ether. So it's going to send you 80 ether. It's not a random amount, it's a calculation.
As in like the integer that you're putting in, is it just some U8256? What is it? How do you know it's Ethereum?
Oh, okay, so when you use .send or .transfer, right, the number that you put in is always in terms of like Wei or Ethereum, or Ether basically. Yeah. Yeah. In the send field. Okay, but why would the send fail? Okay, but that's not like usually the send wouldn't fail. You can change this to .transfer. Let's assume it's .transfer. It will still work. Yeah, try.
But is the Ethereum variable type an integer? Like can you just times something to weigh? Like just times 4 over 100.
So the currency amount is usually in unsigned integer. Yeah, so you can just multiply. Yeah.
Isn't what's stopping you from choosing 100 over 100?
What is it?
What's stopping you from just changing your code to 100 over 100?
So this code, right, is already deployed on the blockchain, so it can't be changed. Yeah, you're talking about this 4 divided by 100, right?
Yeah.
So this is a smart contract. Then you're calling this function. But this function is already like hosted on the blockchain, it can't be changed.
Yeah, like when he coded the code, right, how is there like why is it 4?
So okay, this 4 is just to tell you that you're getting a 4% investment return on whatever money you put into the smart contract. Yeah.
If you're putting a different number, then people would see it as a different.
Yeah, but the 4 doesn't really matter.
You could, but like.
But isn't this a Ponzi?
Okay, correct. Why?
Alright, cause after a while you'll run out of money, right?
Yeah.
Say if only 1% does this, it will run out in 25 days, right? Yeah. But if other people put in more money, you can last more than 25 days. Correct?
Okay, so what Derek says is actually correct. Okay, so take a look here, right? You have this mapping at block. Okay, so everybody's address is mapped to this like number, the block at which they last called this function. Okay? So over here, let's say you call this function, okay? Then at block of your address is equals to block.number. So let's say the first time I call this function is at block 1. So inside at block, right, my address will be linked to number 1. Okay? Then the next time I call it, let's say it's block 10,000. Then it'll be 10,000 minus 1 divided by 5,900 times 0.04 times whatever I invested. Okay, so I'm getting back some money. And then my app block will be changed to like 10,000 basically. But the key point here that you can see is that the amount that you're getting back, right, is determined by the amount of time that you wait in between your investment, correct? So let's say let's say I'm the owner, I invest right on the very first day. Then I wait like maybe like 5 years. Okay, so now this number here is going to be very huge, correct? Because I waited for a very long period of time. And then I tell you, okay, now you can invest some money into it. Then when all of you guys invest money into it, right, I just withdraw the money. So that huge number times 0.4 times 0.04 times the initial amount I invested is going to withdraw a huge amount of money out of the smart contract. And all of that money actually came from you guys. Right? You guys follow? Yeah.
Although that is true, but it's, to me, I feel like it's an interesting game as well. Because, like you said, it will be dangerous if someone put into a lot of money at first and then wait for a very long time to wait until the block number minus the app block to be very huge. But that's under the assumption that there are a lot of people, after seeing me as the one of the earliest investor, after seeing me, they still want to get in. So it's like a more game theoretical. You don't know how they will react. So the reason why I can withdraw that much money is because under the assumption that they will also follow me and further invest. And under the assumption that they didn't withdraw before I did.
Okay, yeah, true.
Right?
No, but if they withdraw before you, they wouldn't withdraw as much. It would just be very little.
They wouldn't, but I wouldn't be able to withdraw as much as I want as well.
True, yeah.
Right? So I think it's a game theoretical. It's very interesting.
So, in a way, like to Alex, it's like not really anything wrong with the code. Like not anything morally wrong with this contract.
Yeah, it's
But
kind of like
yeah, what Derek said is true. It's kind of like a Ponzi scheme.
yeah.
So like the more people who invest after you, the more you are like more likely you are able to like make it rich off of their money. But then for them they can make it rich off the people afterwards. So it like carries on and on and on. So basically the last person to invest is just gonna get like screwed by this. Yeah. So there was nothing wrong with the code written. Right? It's already deployed on the blockchain and it's correct.
And I think there's another bug. If
Mm.
you think about it, if I wait long enough,
Mm.
I wouldn't be able to withdraw any money at all, because the amount is gonna exceed whatever has been stored into this smart contract,
Oh wait.
right? This amount is just gonna exceed.
Oh then you just feel it.
I just fail, and I won't even be able to withdraw the initial deposit,
I mean if you
right?
but if people keep investing, eventually there should be a day where you can withdraw.
No, you can imagine. Okay, imagine I'm an extreme case. I'm the only one who invests.
Oh yeah.
And I wait 5 years after that, and then I wouldn't be able to withdraw whatever that initially
Oh,
deposited,
yeah.
right? Because the amount is going to be too big that the cent is going to fail.
Yeah. Okay,
So-
yeah.
So means your block will change with time.
Yeah. So block that number. That is a built-in function. It's a built-in variable. So it means that the current block number is the block height. Yeah. So
But nobody else invested, so isn't it the same?
no, it's not. The next time I call it, block the number is definitely going to change, right? Because there's new block in mind. Block height is going to change.
So do you know what do you know what the block is essentially? What number would that be? So
Block that number. It's the number that I call this function.
no, as in the after add block.
Add block is the last time I call this function.
So if you're the only one calling it, do you know what maybe or
If it's what?
Oh, he's asking like when you call this function, do you know what the block number is? Is it?
Yeah.
yeah, and then what the block number is?
You will roughly
You roughly know.
you roughly know.
It's like for example, right now we know the last block that's being mined is at block height number 100, for example. Then you roughly know like your transaction probably will get either included in the next block or I don't know next 10
Yeah,
blocks.
like block 110, 105, something around there.
Yeah, you wait for a while and then your transaction will get.
And if it's really
Yeah.
low,
So it's a range thing.
Yeah, okay. So yeah, I just wanted to share this with you guys because I thought it was pretty interesting. Yeah. Yeah, so don't get scammed. But if you're like Alex, you want to challenge, then go for it. Okay. Yeah, so when you guys go back, you can review the slides, look through the Solidity syntax. If you want to learn more, I put some links here, so you can read the docs or learn X and Y minutes, which is where most of my content came from. Then there's also a diagrammatic interpretation of the Ethereum blockchain. This is a pretty hardcore image that you guys can go and take a look at. Let me just show you. It kind of looks like this. So, but with what you guys have learned so far, it should be possible to understand this diagram if you go through it slowly. So on your own time, go and look at this and try to understand, try to consolidate your learning. Okay, and then lastly, there'll be a quiz. So upload your Solidity code into the quiz.